Hello and welcome to our lesson on applications and problem solving. This is going to be from section 1.3 in our text. In this lesson, what we're going to focus on is word problems. We're going to look at how to set up and solve word problems, okay? I know this is your favorite, so strap in. Let's get started. First problem we're going to look at here, number 3, it says a city park. We've got a city park, and if you look at the picture, it's in the shape of a triangle. The residents of a downtown neighborhood designed a triangular-shaped park as part of a city beautification program. All of that is irrelevant except for the fact that it's a triangle. It says the park is bounded by streets on all three sides. And then it says the second angle of the triangle is 7 degrees more than the first. There is our first critical piece of information. The second angle is 7 degrees more than the first. So, what does that mean about the first angle? It means, well, we don't really know what it is, and so it's going to be x. I don't know what the first angle is, so we're going to designate that as x. Now, if you look over here at your picture, you're going to see that they've already designated this angle as x. And so what we'll do is we'll label that the first angle. That'll be the first angle. Now, for the second angle, it says the second angle is. So the second is in math is equals. It is 7 degrees more than the first. So the words more than means add, and that means they're adding 7 to something. 7 degrees more than the first means they're adding 7 to x. So that would be our second angle. And you can see that that is designated here for this angle in the picture. So we're going to label him the second angle. And now it says the third angle is. So we can say the third is 7 degrees less than twice the first. Whew, lot to break down there. First of all, the words less than mean minus. So we're going to have a subtraction. And what's interesting about less than, whatever's in front of the words goes at the back of the minus. So 7 degrees less than means you're subtracting 7 from something. Twice the first means 2 times the first. And remember, the first was x. So that's going to be twice the first, or 2 times the first. And that's what we're subtracting 7 from. Notice in the picture, they already have that labeled, 2x minus 7. So this would be our third angle. And now that we have all three angles designated algebraically, we can set up an equation to solve. But you're going to need to know a characteristic of triangles, okay? Here's what you're going to need to know. All three angles add up to make 180. Okay, that's what you need to know about triangles. If you add all three angles, it always makes 180 degrees, no matter the shape of the triangle. And so now for our equation. The first angle is x. The second angle is x plus 7. And the third angle is 2x minus 7. So do you see? Look, I'll do it in blue. If I add all three angles, what should it equal? It should equal 180. And now I have an equation that I can solve for x. So let's combine like terms. X plus 2x That's going to give me 4x, 7 minus 7, plus 7 minus 7. Hey, those cancel. And I'm left with 4x equals 180. And then if I divide both sides by 4, I'm going to have my x by itself. That'll be the answer for the first angle. So what is 180 divided by 4? Well, if you're like me, you want to make absolutely sure you're going to use the calculator. So 180 divided by 4, 45. So our first angle is 45 degrees. Now, what is the second angle? Well, remember the second angle is x plus 7. Now that I know that x is 45, I can substitute and I can work that out and get the second angle. Okay, so this is the first angle. The second angle is going to be x plus 7, which is 45 plus 7, which is 52. And so there's our second angle. And then the third angle is 2x minus 7. So let's write that right in here. The third angle is 2x minus 7, but I know x is 45. And so 2 times 45 is 90. 90 minus 7 is 83. And that would be our third angle. Now, just to check and make absolutely sure you haven't screwed something up, what we can do is we can pull up the calculator and we can add all of those angles together. So 45 plus 83 plus 52. And if these are right, then this should make 180 because all three angles have to add up to make 180. And that verifies that what we did is correct. And that's it for the first example here, setting up and solving a word problem. Next, number 11, we're going to look at a rope cutting problem. It says a rope that is 168 feet long, that's important, is to be cut into 3 pieces. So the first thing I'm going to do, since I don't have a picture, is I'm going to draw a picture. Here's my rope stretched out as a straight line. And since it's going to be cut into 3 pieces, that means there's going to be 2 cuts, such that the second piece is 6 feet less than 3 times the first. Do you see the second piece depends on how long the first piece is? And they don't tell me how long the first piece is. So what I'm going to do is I'm just going to say, hey, I don't know, that's X. That's the first piece is X. Once I have the first piece identified, then I can get the second piece because the problem says it is 6 feet less than. Remember, the words less than mean minus, and whatever's in front of the words less than goes at the back of the minus. 6 feet less than 3 times the first. 3 times the first. And so that's how you represent 3 times the first. That's 3x. And that would represent algebraically the length of the second piece. Now, the third piece is 2 feet more than 2/3 of the second. Whoo! Let's translate that. 2 feet more than. More than means add, and that means we're going to be adding 2 to something. 2 feet more than. 2/3 is a fraction. The word of in math means times. And what are we going to multiply 2/3 times? The second angle. And so what I'm going to have to do is I'm going to have to Erase this to create a little more room. 2/3 of the second. Well, what was the second? The second was 3x minus 6. So I'm going to be multiplying 2/3 times 3x minus 6 because that was the second. And then I'm going to be adding 2 to that. Man, this is going to be exciting. So, what do you think would happen if I add all three pieces? What should it equal to if I add all three pieces together? Well, it should equal the total length, which was 168. And do you see now I have an equation that I can solve for x? I've got the first piece was x. The second piece was 6 feet less than 3 times the first. 6 feet less than 3 times the first. And then the third piece was 2 feet more than 2/3 of the second. Let's go ahead and get started. So, I'm going to simplify this equation first, and then I'll worry about combining like terms. We've got x plus 3x minus 6 plus. Now, at this point, I'm going to take and distribute the 2/3. And if you want to use the calculator, you can. This is not going to be too bad since both of the 3 and the 6 divide by 3. So 3 goes into 3 one time. 1 times 2 is 2. That's going to be 2x. 2/3 times 3 is 2x. And then 2/3 times negative 6. 3 goes into 6 2 times. 2 times 2 is 4. That gets rid of the parentheses. Don't forget about your plus 2 equals 168. Now that I've gotten rid of the parentheses, which notice also got rid of the fractions, hallelujah, now I can combine like terms. X plus 3x plus 2x. All together, that's going to make 6x. And then I've got constants, -6, -4, and plus 2. -6 and -4 is -10. Plus 2 would be -8 equals 168. And at this step, it's a couple more steps and we're done. Bringing the -8 over makes it a +8. That's going to bring down the 6x equals, what is 168 plus 8? That is going to be 176. And then if I divide both sides by 6, man, I hope that divides evenly. Let's pull up our calculator and see. 176 divided by 6. Oops, it's not a nice number. 88/3 is not a whole number. I wonder what that is as a mixed number. Can my calculator do that? Look at this. It sure can. If I hit Shift SD, it'll give me that answer as a mixed number. How freaking cool is that? So the first piece of the rope is 29 1/3. So let's label that over here. The first piece is 29 1/3 feet long. If I know that, can I find the length of the second piece? Well, yeah, the second piece was 3x minus 6. And so what I can do to figure that out is bring up my calculator. I want to actually go back and use the 88/3 for this. Plugging in for x, that's going to be 3 times 88/3 minus 6. Now, do you see what I did there? I took the length of the first piece and I plugged it in for x into this expression for the second piece. 3 times 88/3 minus 6 equals, now that is going to be the length of the second piece, 82 feet. And then to find the length of the third piece, okay, bringing the calculator back up and looking at the expression that we had. Now this is a little complicated, so what I'm going to do is simplify this for you. Remember this here, all of this was the second piece. And so now that I know the length of the second piece, I can simply plug that into this set of parentheses. I don't actually have to rewrite all of this junk. I just need to plug the second piece in there. And so pulling up my calculator, that's going to be 2/3 of means times 2/3 of the second, which was 82 plus 2. And that's an improper fraction as a mixed number, 56 2/3. And so that length is 56 2/3 feet. All right, so let's look at what we've got here. We've got the length of every piece. And what I'm going to do is I'm going to use my calculator to check and see if I'm right. If I add all three pieces, let's see, 29, shift fraction is a mixed number, 29 1/3, plus 82 plus 56 2/3. If I add all three pieces, it should equal 168 because that was the length of the original piece of rope. So at least this verifies that my lengths are correct based on my algebraic interpretation of the problem. Okay, so that's good. Now let's go back and see what they actually wanted us to find. It's always important that you give the answer they ask for. What did they really ask us to find? Find the length of the longest piece. So which one of these would be the longest piece? Well, that's going to be the 82 feet. It is the longest piece. And so that would be the answer that you give on a test or that you input into your MyLab Math. Whew, that was a tough one. Man, let's move on to the next one. Number 17, interstate mile markers. U.S. interstate highways post numbered markers every mile to indicate location in case of an accident or breakdown. Okay, this is the important part right here. Every mile they put a marker. In many states, the numbers increase from west to east. The sum of, all right, so that's a math term. The sum of two consecutive mile markers is 495. Let's break that down, okay? First of all, the word sum in math means add. We're going to be adding two things, and it is going to be 459. 459 is going to be the sum of the two mile markers. And then the next word that is absolutely critical, it says these mile markers are consecutive. That means one right after the other. So the first mile marker plus the second mile marker should equal 459. So what I need to know is, what are the numbers on these mile markers? How many miles was written on the first mile marker? I have no idea. And so what I'm going to do is I'm going to say, I don't know, that's an unknown. I have no idea what the first one is. But I do know that they're consecutive. And it does not tell me whether I'm going east to west or west to east. That's not actually given in this problem. So that means we're going to have a little bit of freedom, I guess you could say, as far as how to algebraically establish the second mile marker. So if we're going from west to east, it says that the numbers increase. So let's just assume for a second that we are going west to east and these numbers are increasing. If the mile markers are consecutive, then they should increase by 1. So whatever the value is on the first marker, the second one would be 1 more than that. And since I have no idea what the first one is, the second one is going to be x plus 1. Whatever the first one said, the second one will be 1 more than that. Now remember, this is the setup if you're going from west to east. Now, let's play the what if game. And let's say, what if we were going east to west? How would that change the way we set up the problem? Well, the first one would still be unknown. I still have no idea what the first one is, but if I'm going from east to west, then the number should decrease. And so the second mile marker would be whatever the first one was minus 1. So do you see the way you set up the problem is going to be a little bit different based on whether you decide that you're going east to west or west to east? My question is, are we going to get the same answers either way? Well, let's find out. Okay, so for the first equation, if I add like terms, that's going to give me 2x plus 1 equals 459. Bringing the plus 1 over makes it a minus 1, 458, and divided by 2, that'll give me x, and remember, x was the first mile marker. So what is 458 divided by 2? 229. 229 would be the first mile marker. And so the second mile marker would be 1 more than that. X plus 1 would be 230. And so what does it ask me to find? It says find the numbers on the markers. So if I set it up this way, the numbers on the markers would be 229 and 230. Now let's look at the other one. X plus x is 2x minus 1 equals 459. This time we're bringing the minus 1 over, which makes it a plus 1. That's going to be 460. And then if I divide both sides by 2, what is 460 divided by 2? 230. So here the first one would be 230. But remember, in this problem, the second one was x minus 1. X minus 1 would give us the second. What is 230 minus 1 is 229. And so setting it up this way, if it says find the numbers on the markers, they would be 230 and 229, which is exactly the same answer we got the other way. How cool is that? It doesn't matter which way you interpret it, you're going to get the right answers. Man, that is awesome. And that's the end of that particular problem. Moving on to number 25. This is going to be, I think, the last example we will look at in this section. All right, so looking at what we've got here, internet search ads. The number of internet paid search ads is increasing as advertisers move away from traditional marketing methods. The equation, let's go ahead and outline that. This equation can be used to project spending on internet search ads in billions. That's kind of important. This is in billions of dollars. X years after 2012. So what we get from that is that X is going to represent years after 2012. So if X is years, then the Y is going to be dollars in billions. And so now that we kind of understand what the variables represent, we can look at maybe answering some of these questions here. Part A, estimate the spending on internet search ads in 2014. Well, since X is the number of years after 2012, what we want to do is take that given year, 2014, minus 2012, and that'll tell us what our value of X is. And so in this particular problem, 2014 minus 2012, that means we're looking at 2 years after 2012. What am I going to do with this 2? Well, I'm going to substitute it into my equation. Y equals 6.5 times 2 plus 41.6. And I highly recommend the use of the calculator for that. So we're going to have 6.5 times 2. Notice I can do times 2 or I can do the parentheses. Either way, it's going to multiply that plus 41.6 equals. Now, on my particular calculator, the calculator always gives a fractional answer as the default output if it can be a fraction. I would really prefer that this is a decimal, so what I'm going to do is hit this SD button, and that forces a decimal. So that's going to be 54.6 as my answer. 54.6. Remember, we said Y is dollars in billions. So that's going to be 54.6 billion dollars. That's how much is projected on internet search ad spending. That's how much companies are going to be spending on internet search ads projected in 2014. Okay, that's what that number represents. Now, for part B, it says, in what year will spending on internet search ads be 75 billion? Notice it says in what year, and since X is years, X is my unknown. I'm going to be looking for X, so that means the 75 billion is Y. And then I'm going to do a little plug and play again. Y, this time is 75. And you don't have to put all the zeros for billion because Y is represented in billions. So just 75 means 75 billion equals 6.5x. X is going to stay X because that's what I'm solving for, plus 41.6. And now if I solve for X, I'll know when this will happen. All right, so here we go. Next step, to get X by itself, we're going to bring the 41.6 over. That'll make it a minus 41.6. And I'm going to use my calculator for that just to make sure. 75 minus 41.6. Yeah, fraction, that's easy. Decimal, 33.4. 33.4 is now 6.5x. And then if I divide both sides by 6.5, we're going to hope and pray that this fraction works out to be a whole number. All right, so we've got 33.4 divided by 6.5. It's not a whole number. SD 5.138. 5.1. Okay, let's write that down. 5.138. That would be in years. Now let's read the problem. Since it says in what year, we'll assume that that has to be like a whole number, like 2020 or something like that, which means that this number that we got for the number of years would need to be rounded to the nearest whole number. We can make that assumption. So 5.138 in years would be approximately 5 years. Now, don't forget that this is the number of years after 2012. And since it says in what year, we're actually going to need to find the year. So that would be 2012 plus 5 because it's 5 years later. And that's going to be in 2017. And that'll be the answer for part B. And we got the answer for part A over here, 54.6 billion. And that answers all the parts of that problem. Yay, so we're done. Not only are we done with that problem, we're done with this particular lesson. So if you have any questions or comments, feel free to leave those in the comment section below, or you can text me. And thanks for watching.